Again, we're only dealing with a natural logarithm at this point, but the natural logarithm rule is really easy to deal with. Again, let's just write down the rule so that we know it. The derivative with respect to x of the natural log of some quantity u, where u is a differentiable function of x, will be equal to the derivative of u divided by u itself. Uh, this is probably one of the easiest rules on the books outside of the derivative of the function y equals e to the x. So, what will we do here? In this case, we can take a derivative of something like this, right? If we wanted to take the derivative just using this rule directly, the natural log of x over x squared plus 1, well, does that mean that I'm going to take the derivative using my quotient rule of x over x squared plus 1 and divide it by x over x squared plus 1? Well, I could do that, but it's more difficult to deal with. You have to deal with a quotient rule. And the nice thing about logarithms is that there are certain rules that we can use to rewrite them. And rather than having to deal with a quotient, we can deal with a sum or difference, in this case a difference. We can rewrite this logarithm before we even get near having to take a derivative. So let's do that. In this case, we're going to use our quotient rule here, rule B, that says if you take the natural log of a quotient u over v, it's equal to the natural log of u minus the natural log of v. So we've got y equals the natural log of x over x squared plus 1. Rewriting it using our properties, this is the same as taking the natural logarithm of x minus the natural logarithm of the quantity x squared plus 1. And now, if we want to find the derivative of y, well, let's use our rule. The derivative of the natural logarithm of x, we said is equal to the derivative of x, which is just 1, divided by x itself, minus. Now we take the derivative right here. We could say, well, the natural logarithm of x squared plus 1 is the derivative of x squared plus 1, that's 2x, divided by x squared plus 1 itself. Now, for the most part, if we're just interested in getting a quick down and dirty derivative, that's it. If we wanted to, we could combine these two fractions together to make it into a single term. That would require a little bit more algebra. Right, remember that would mean we'd have to get a common denominator. So we'd have to take x times the quantity x squared plus 1, since they don't share any common factors. And I'd have to take x squared plus 1 and subtract from it 2x times x. So the denominator over here times 2x, the denominator x squared plus 1 times 1. And then simplify, y prime would become 1 minus x squared divided by x times x squared plus 1. So we should be prepared to do that if we need to, but look how fast our derivative came out initially. This is good stuff.